Hello all, welcome you all back to this Industrial Engineering and Management subject. In this video, we'll discuss about the next half of your syllabus. The contents which are marked in red are the ones which we'll be seeing in this video. We'll see about the different charts which are involved in the recording techniques of method study. We'll start with outline process chart, flow process chart, handed process chart, SIMO chart, and your micro motion study techniques. What is outline process chart? It is basically a visual representation of all the major operational activities which are carried over in an organization. The major objective of an outline process chart, it helps you to minimize the various flow process chart or the forms of various flow process chart, and it focuses only on providing the overview of the whole process. It gives you a similar kind of a bird's eye view of what the process is about, and it helps you to find out what is the sequence of operation which has been carried over. It doesn't give a deeper insight or doesn't give you any detailed information regarding each and every steps involved in the process, but the overall flow of the process can be seen through this outline process chart. An outline process is constructed in a way that the operations are mentioned on the right side, whereas the time taken to complete that is mentioned on the left side. An example of an outline process chart is shown here. This is something, the example which we have taken related to the making of biscuits. First thing is we start with the process where the complete raw material is put into a molder. So once that mixing process is done, then the molding of biscuit starts. As informed earlier, or you could see that the operations which are carried over in the entire process, molding of the biscuits, then biscuits to oven transformation, then the baking of the biscuits is done, then the biscuits have been cooled in the cool trays, then they are moved on the inspection lines, finally they are moved for packaging and distribution in the shipping boxes. All those processes are mentioned on the right side, whereas on the left side it is indicated the time involved for each and every process. And these are the symbols which we have studied in the previous video, the method study symbols. The arrow mark indicates your transportation, the circle indicates your operations, and D refers to the delay which is happening. The corresponding sequence of numbers indicates the subsequent numbers for the respective symbols. If in case due to inspection there has been any rejection which has been happening, even that has to be mentioned here, which means that the rejected products will be moved out of the assembly line or the process line. They will be moved to a scrap, so that will be indicated through a transportation, and the corresponding time involved is also mentioned here. Then you will proceed with the remaining products which are considered to be acceptable limit, quality limit, which is called as AQL, the acceptable quality limit, and that will be continued for the next flow process. The second chart which is used in the method study techniques, recording of method study techniques, is your flow process chart. It is basically of two types, man type and material type. What it gives you is the sequence of workflow of the product. How far it is different from an outline process is that outline process doesn't give you the deeper details about or the clear detail about each and every steps involved. It gives you only the overall process involved, whereas flow process chart will give you a deeper insight about what are the steps involved in each and every process. The other operations being the same, being inspection, storage, delay, and the symbols correspondingly used are almost similar to what has been used in the method study symbols. An example of your material and man process chart has been shown here. So as similar to what your outline process chart is about, your flow process chart is also denoted by the operations on the right side and the corresponding numbers, the time taken on the left side. You could see that first thing, man type is, it only deals about recording activities which a particular person. Here the man refers to the worker who is involved in the process. So first thing is he is moving out to receive the goods. Once he is moved out, we call them to be transportation. Second thing is he's locating the component and pick out the components, which is a kind of operation involved. So that is denoted by the circle. Then he is moving on to the inspection department, and he then setting up the component to bench. So all the operations, you could see the corresponding numbers, the operation 1, operation 2, operation 3. So the subsequent numbers has to be followed. If in case a new particular symbol is followed, then you have to denote it using the particular symbol. Say for example, any delay is happening, D is mentioned here, that has to be given as number 1, and the subsequent delay will be given as 1, 2, and 3. And the right side is your material type flow process chart, where the focus is only on the material. You do not focus on the workers or the humans who are involved over there. The only the for in case of the example which we have seen earlier, here the material refers to the biscuit, so it's completely deals only with the biscuits which are being involved in the particular process. You will not look up to the workers here. How far is your flow process chart useful? It helps you to reduce the distance traveled by the men or material. That is the key important aspect of method study. I keep on repeating the same point because method study is the only technique which will consider the worker as well as the process into the studying equipment or studying methodology. Other technique usually considers only the process. So it helps you to reduce the distance traveled by the men or material, thereby reducing the overall fatigue of the worker here. And it also helps you to avoid the waiting time, through which you can implement the concept of just in time, which is in a nutshell bringing the right product at right time and at the right place. And it also helps you to reduce unnecessary delay. Again, you can bring in the concept of reducing the bottleneck and starvations, and the overall cycle time can also be reduced. It also helps you to fix up the sequence of operation and relocate the inspection stages. It need not necessarily be that the inspection has to be carried out or it has to be done only at the last stage of your process flow. The inspection can be done then and there to ensure that the product is meeting the required standard whenever it is moving out of each of the process stage. The next chart we are going to see here is two-handed process chart. What it is almost an upgraded version of one-handed process chart. Even though one-handed process chart was the first one to be implemented, it traced the movement of the hand throughout the process. Now, say for example, we there are a few examples which we can quote. A student writing an examination, we are the process, the hand process or hand movement which is involved for a particular person when he is having his breakfast or lunch. So rather than tracing a single hand, the two-handed process chart traces the movement of both the hands together, one for the left hand, the other for the right hand. So it helps you to analyze how much of time is both the hands are completely involved in the process. A person who is predominantly right-handed, it has to be ensured that majority of the operations is done doing by by the person using his right hand. If in case during analysis you found that the person has been, the system has been or the process has been made in a way that his left hand has been used predominantly, we have to make sure that there is a different improvised method which is being implemented to ensure that a right-handed person predominantly uses his right hand for majority of the operation. So the symbols as similar to what has been used in your method study, an operation, transport, delay and hold. Instead of storage, we are using an inverted triangle here for hold. Hold refers to the particular place where the person doesn't do any process, but more specifically the particular hand doesn't involve in any process. Here are the few examples. We'll zoom in a bit and we'll see about the nut and bolt assembly. What is the left hand doing and what is the right hand doing? Probably people can try it out with the, any nut and bolt assembly which you find in your places or in your labs nearby. The left hand predominantly deals with the reaching of the bolt, the grasp of the bolt, and this nut and bolt assembly handle process chart is designed or it has been framed for a person who is predominantly a right-handed person. So this chart will help you to analyze the number of operations every hand is doing. Now the summary has been denoted here. You could see that the the right hand is not used predominantly for any hold or delay, whereas for a left hand, hold or delay, the 2 times the left hand has been used for holding and 2 times it has been used for transportation. A person who is predominantly right-handed will not be using a right hand for holding because right hand is one which is more comfortable for the person. So the number of operations he is doing using his right hand is 5, whereas the number of operations he is doing using his left hand is 2. So this has to be ensured that it has to be vice versa if the person is a left-handed person. So this chart will help you. So this may, when you put it on an different n number of cycles, this may look like very small numbers, but when you calculate it for a week time, a month time, a year time, you could see that the person should not be facing any fatigue due to the operation. He has to be very comfortable in doing the work. So this handed process chart will help you to track those data, and through which you'll be able to provide or suggest any improvised method through which he will be facing a very lesser fatigue and more comfortable in doing the job. The other example quoted is much more relevant to you guys, since what has been here is both the hands has been traced for a person who is writing the examination. Again, it's predominantly a right-handed person who is doing the job. So you could see there writing of examination, holding of the sheet is your left hand. During the entire course of your examination, 3 hours or 1.5 hours or 2 hours, whichever is the duration, we usually use your right hand, and you could see that majority of the process here involved refers to operation because there is no very lesser amount of delay during the examination. Examination is meant for writing examination. Predominantly, the operations are involved, so there is no such of delay which has happened. You can apply this to any process, be it preparation of a coffee in your home, or be it preparation of any food items, or you even think about the two-handed processor when you are driving a car, how much of time you are replacing it, maybe an automatic car or whatever it is. So the applications are varied that you can use it for a number of applications. Next, we will see about principles of motion economy. So why principles of motion economy is to be studied is, this is where you study the overall ergonomical aspect of a particular person. You have to consider the ergonomics factor also, because that plays a crucial role in improvising the overall efficiency of the worker. So principles of motion economy are basically a set of rules and suggestions which helps you to improve the manual work in manufacturing, wherein you can reduce the fatigue and unnecessary movement by the worker. So it focuses on application of this technique to the human body, then to the workplace, and to the tooling and equipment. Predominantly deals with the material handling. So it applies to all the three places where the humans are directly involved in the process. Now we'll see the most important topic of Unit 2, which is thermalics, because thermalics are the key important aspect through which you'll be able to measure the motion or the ergonomics of the worker. There are basically 18 kinds of elemental motions. These elemental motions are being framed by studying for a number of cases through which they have been identified that any worker who is doing any type of job, be it in a manufacturing or a service related sectors, a worker who is involved in any process will obviously use these 18 kind of elemental motions during this entire operation. So the work is, actually this, the name how does this thermalics refers to is, it was derived by, it was framed by a person called Gilbert. So this is derived from the same name of the person, which is spelled backwards with the th being transposed. So thermalics refers to more precise and detailed description of the work than any other methods so far. So it is one of the most demanded techniques of recording techniques, which is used for studying the ergonomics of motion. A good example is, many of you would have seen about, heard about the news of cricket players who are being banned for illegal bowling action. A good example is Muthaiya Muralidharan, who has been banned for a good number of time because his hand was bending to a greater extent when compared to the allowed permissible limit. So his entire motion was analyzed through micro motion study, where thermalics were used completely to analyze whether he is in line with the required standard. There are many such examples which you can quote for your thermalics. So these are your 18 elemental motions which are predominantly used. The first one is your search, which is focusing on your eyeball movement. And once you search for the product or the component, you will find it. Then you will use the symbol of select. If you want to grasp the product, you use the symbol. Then for hold. And point to be noted here is, everything is having a different color code. It is not that all these symbols are used directly. Every symbol has a unique color code, and those unique color code refers to the particular work which is being carried out. So these are the 18 elemental motion, including your inspection, release of load, unavoidable delay, planning, resting. All those symbols are used if you want to study the ergonomics of a worker who is involved in a particular place. So ergonomics of a worker is studied through recording techniques of motion study. So in motion study, this thermalics plays a very crucial role. Almost every process or every worker who is doing any kind of work will have any of these 18 elemental motion incorporated in his work. Now we'll see a basic example of how thermalics is developed. The operation here is refers to a sewing machine, which is predominantly used in your boutique shops. So operator name and the date has been mentioned here, where you will create a workplace layout, and more importantly, you will look up to all the important activities of it. Your left hand and your right hand, all these activities are individually noted down, and the corresponding thermalics code are noted, through which you will be having an respective thermalic symbols, and the time taken for each of it is also noted. That will give you a clear indication about how much of time the particular person is taking out to do the particular work. So this is carried out for a person. You could see that there are so much of ergonomical aspect. Whenever person is transporting empty handed, you use this particular symbol, and the time taken in terms of seconds is to be noted. And once that person has finished the work, then you will completely stop recording this activity. You can use this chart for any kind of different activities in your home. As I said, it can be a non-technical activity too. So I'm quoting up this example only for you people to have a quick reference about it. Next one is your SIMO chart. SIMO stands for simultaneous motion chart. So it is based on film analysis, where you record the common scale of thermalics. right? And the different thermalics performed by different parts of the body. And what is the uniqueness of Simo chart is that, as the name simultaneous indicates, it simultaneously records all the activities of different workers. Whereas your normal thermalics, you use it only for a particular single worker on a common time scale. So whereas simultaneous motion chart analyzes, now say for example there is a plant, or you could even take out the same example. If there is 10 workers who are involved in doing the saving operation, and 10 workers are having their own work table. So Simo chart helps you to analyze each of those 10 workers simultaneously when they are doing the job. It helps you to compare or find out which of the worker is meeting the required standard at the required time, which of the worker is facing difficulties. It is not about fault finding, it only helps you to improvise the working condition of the worker. So since it is measured on a common time scale, rather than mentioning it as seconds or minute, the time measurement here is mentioned as wings. So one wing is 1 by 2000 minute is the measurement time which we use it for your Simo chart. So the thermalic symbols are correspondingly mentioned here, which is also explained in your previous slides and previous videos. So for each of the tasks noted, you have to have a clear thermalic symbol which is mentioned, and each time has to be recorded. Corresponding time, the cumulative time will be calculated, and you have to find the possible ways of improvising them, be it in terms of number of activities for each of the hand, or be it in terms of number of seconds or number of wings you are reducing in terms of minutes. Whatever it is, the Simo chart will always help you to find the cumulative value of which has happened in an entire plant or an entire process. Next thing is your micro motion study. Micro motion study is a technique used for analyzing the operation based on timing. So a micro motion study is usually recorded using a video camera which is running at a prescribed speed. A known speed refers to a standard speed in which it is being operated. The speed of the camera usually ranges from 960 to 1000 frames per minute, but due to advancements currently which has happened over the years, there are much more faster cameras which we use for faster hand motions or complex operations, because there could be a different complex operation. A good example is probably one of your senior student have used this given a suggestion of using this for a person who is tying up flasks, right? His hand movement will be very fast, that you have to record it in a much more quicker manner. So even the current trend has given faster cameras to measure very fast hand motions. So a micro motion study should be used when it is economical, because since it involves utilization of camera which is quite costly, you have to look for options where higher repetitive operations are carried out and large volume of productions are being carried out, and more importantly, it should have a very shorter cycle time. If there is a cycle time is large, then you should find alternative of using some other motion study rather than a micro motion study, because investing in a camera is going to cost or additional cost to the industry. So it is to be used only when it is economical to do so. The next one is your memo motion study. Memo motion study, the camera speed is very less when compared to micro, 60 to 100 frames per minute. So it is a kind of a time lapse cine photography. The time interval usually lies between the range of half second to 4 seconds. So you can have 10 or 20 minutes of video which may be compressed to 1 minute. And a memo motion study is a type of a time lapse photography, because it helps you to analyze each and every aspect in a much more detailed way. Rather than recording it in a more faster way, it is a time lapse cine photography, so that you can measure each of the angle and each of the seconds in terms of microseconds you can measure. So advantage of memo motion study is that you can measure in terms of microseconds. But a memo motion study was the one which was first implemented in time study techniques. Later it has been improvised to micro motion study. You could see the speed here limit, right? Earlier it was 60 to 100, then it has been made to 960,000 frames. So higher the number of frames, higher the precision and higher the accuracy with which you can analyze them. We will stop with this video for this content, and we will continue with the remaining contents in the next video. Thank you.